Good morning to all my YouTube viewers. In this video, I like to discuss about 2020's JEE Main's physics paper, which took place on 8th January in the morning shift. This video is an extension of the previous video. In the previous video, we have already discussed 16 questions. Now here, from 17th we will start. In finding the electric field using Gauss law, the formula E equal to Q enclosed divided by epsilon naught mod A is applicable in the formula. Epsilon naught is permittivity of free space, A is the area of Gaussian surface, and Q enclosed is charge enclosed by the Gaussian surface. The equation can be used in which of the following situation? There are four choices. Now in solution, we know that electric field is perpendicular to the surface and magnitude of electric field remain constant, and in Gaussian surface it is equipotential surface. Now in the choice 1 it is found only one condition is able to satisfy, and number 2 there also we find only one condition satisfied, that is equipotential surface, but number 3 there is no such conditions are satisfied. Number 4 there are two conditions are satisfied, equipotential surface and E is constant on the surface. So number 4 can be the best answer for this. Now question number 18. A thermodynamic cycle X, Y, Z, X is shown on a VT diagram. There are 4 PV diagrams are provided, and in the question VT diagram also provided. Now in solution, from VT diagram to PV diagram, we know that PV by T equal to constant, and from X to Y it is found that this line is passing through origin and it is straight line, so pressure has to be constant here. As V and T changes, pressure has to be constant. So on PV diagram, X to Y drawn, keeping pressure constant, volume increases. Now for Y to Z, we can see keeping volume constant, temperature decreases. So for PV diagram, Y to Z, we can see as temperature decreases, pressure has to decrease. So it will straight come down from Y to Z. Then from Z to X, we can see temperature constant, volume decreases, therefore pressure has to increase. Now on PV diagram, it has to be Z to X, isothermal compression, and it will come back to position X. And this diagram is not matching with the given 4 diagrams. Only number 2, it is found that if Z and Y are interchange their positions, then it will match with this answer. Otherwise, this diagram will be the answer. Next question, question number 19. Now, the graph depicts the results of Rutherford gold foil experiment with alpha particle. Is theta is scattering angle, y the number of scattered particles detected. Plots are systematic and not to scale. There are 4 diagrams are provided. Scattering angle theta varies inversely as sin to the power 4 theta by 2. That is n function of theta inversely proportional to sin to the power 4 theta by 2. But theta tends to 0, y is infinity, tends to infinity. When theta tends to phi, x will be towards 1. So answer, graph 1 is the best answer here. So we will mark for number 1 plot. Now question number 20. Proton with kinetic energy 1 million electron volt moves from south to north, it gets an acceleration of 10 to the power 12 meter per second square by an applied magnetic field, which is west to east. The value of magnetic field, we have to find out value of magnetic field. There are four choices. Rest mass of proton is given 1.6 × 10 to the minus 27 kg. We know kinetic energy equal to half mass of proton v square, which is provided 1 million 1 into 10 to the power 6 electron volt. From here we can find out V equal to root 2 10 to the power 7 meter per second. Now as we know that force on a charged particle in presence of magnetic field, that F equal to Q V cross B, and that is equal to Q V B sine 90 degree equal to mass into acceleration. From here we can find out B will be 0.71 milli Tesla. Now come to question number 21. Question number 21, a body of mass 0.1 kg has an initial velocity along x-axis, that is 3 meter per second. It collides elastically with another body. P is the same mass which has an initial velocity 5g along y-axis, that means y-axis meter per second. After collision, A moves with a velocity velocity v equal to 4 bracket I plus j meter per second. The energy of B after collision is written as x by 10 j. We have to find out x to fill the gap. Now initial kinetic energy of both the masses will be half m v1 square plus v2 square. Here half m 3 square plus 5 square will come, that will be half m 34. Final kinetic energy is half m v1 dash square plus v2 square equal to half m v2 dash square, that is equal to half m 4 square plus 4 square plus v2 dash square. Now kinetic energy initial equal to kinetic energy final. Therefore, equaling with the initial and final energies, we can find out v2 dash will be 2, and kinetic energy of the second mass after collision will be half m v2 dash square, that is will be 0.1, which is equal to x by 10 joules equal to 0.1 means 1 by 10, that is x is coming 1. So answer will be 1. Next question, question number 22. Now 1 meter long, both ends open, organ pipe is kept in a gas that has double the density of air at STP. Assuming the speed of sound in air at STP is 300 meter per second, the frequency difference between the fundamental and second harmonic of this pipe is filling the blanks. Now velocity of sound is known, that V equal to root under bulk modulus by density. So keep taking ratios of velocity of pipe which has a gas field and the velocity in air, dividing these two will give us root under B by twice rho divided by root under B by rho, so it will give us 1 by root 2. That means velocity of the open pipe, both ends open pipe filled with gas will give velocity of air divided by root 2. Now frequency for both end open pipe will be 1 plus n within bracket 1 plus n v over twice L. And now n equal to 0 means fundamental, n equal to 1 means first harmonic. So their frequency differences f1 minus f0 will give us velocity of the pipe which is filled with gas divided by twice L. Putting all the data, it will be 105.75 Hertz. Question number 23. A point object in air is in front of the curved surface of a plano-convex lens. The radius of curvature of the curved surface is 30 centimeter and the refractive index of the lens is 1.5. Then the focal length of the lens in centimeter is filling the blanks. We know from lens maker formula 1 by f equal to mu minus 1 within bracket 1 by R1 minus 1 by R2. Here R1 is infinity, R2 equal to minus 30. Putting all the given parameters, we can get focal length will be 60 centimeter. Answer is 60 centimeter. Next question is question number 24. The resistance of 15 ohm, 12 ohm, 4 ohm and 10 ohm respectively in cyclic order to form Wheatstone bridge network. The resistance that is to be connected in parallel with the 10 ohm to balance the network is filling the blanks. Now we have drawn the diagram, 15 ohm, 12 ohm, 4 ohm and 10 ohms respectively, and a parallel where resistance R is connected with resistance 10 ohm according to question that under balance Wheatstone bridge conditions, we know 15 by 12 equal to 10 R over 10 plus R divided by 4. From here solving we can get R equal to 10 ohm. Now next question is 25. A particle is moving along x-axis with its coordinates. X is a function of time, that is 10 plus 8t minus 3t square. Another particle moving along y-axis with its coordinate as a function of time given by y as a function of time, that is 5 minus 8t cube. At t equal to 1 second, the speed of the second particle as measured in the frame of the first particle is given by root under v. Then v in meter per second is. Now positions are given. Differentiating, we can get velocity of particle A, that is 2 meter per second, and velocity of particle B, that is minus 24 meter per second. As these are along x-axis and y-axis, the resultant velocity will be root under 2 square plus within bracket minus 24 whole square. It will give us 580 meter per second. So velocity will be 580 meter per second in between x and y direction. This ends the January 8th morning shift question paper. Now I am requesting all the aspirants, those who are getting interest in this video, they can share it, like it, and subscribe for upcoming videos. I will be very much motivated to give you a lot of videos having vital informations, vital questions, so that all aspirants can achieve their future target in a very systematically, and my wishes are always with you, and you can suggest if anything is required, any modification or any new ideas are coming in your mind, you can suggest to me, and thank you very much.